Welcome to this session of discussion of JEE mains paper conducted on September 4, shift 1. September 4, shift 1 paper, chemistry part, we will discuss. Regarding this paper, there is a particular speciality. Out of 25 questions, they have actually given 18 questions from second year. Out of 25, 18 from second year, giving too much importance to second year, and only the remaining from first year. But that is not the general pattern. In fact, you can expect question from any part in NCERT syllabus. That is what is seen. In one shift, it may be almost equal distribution of first year, second year. But in another shift, there may be more important to second year. This is such a paper. More importance to second year questions. Degree of difficulty is moderate only. There are few simple questions also. Level 3 questions are not at all there. They are all simple question or moderate. Right. We will start from question number 1. Question number 1 is actually based upon a principle in first year, aromatic character of a cyclic compound. You know, this compound can become aromatic if it is having a positive charge there. That means this can undergo heterolysis. That CCl bond can undergo heterolysis, producing a positive charge there. And if there is a positive charge, see, this becomes aromatic. With a positive charge there, it becomes aromatic. All the conditions required for aromatic character are there in this compound. It should be a cyclic compound containing completely conjugated system and also having 4n plus 2 pi electron. Effectively, this system has got 2 pi electron. 4n plus 2 can have the minimum value 2. So, this is aromatic. But when we have a group attached there, a group like OCS3, which can supply electron to this ring, that will stabilize the aromatic system. It will increase the number of contributing structure. For example, the lone pair can be brought over there and this can be shifted here, giving another structure which is this one. So, there is a stabilization by conjugation if there is a OCS3 group there. That gives you the answer actually. But if the group is electron withdrawing, that can only destabilize it, because the positive charge ring, if you withdraw electron, become more positive. So, that way you look at it. So, let all these molecules lose chlorine as chloride. Then the corresponding carbocations obtained are this one for option B, the not option is this one, and A gives this carbocation. What about the other? This will give the carbocation CH3, CH plus CH3. And this will be another carbocation which is this one, CH plus followed by CH2NO2, CH2NO2, this way. Anyway, this double bond is not in conjugation with the positive charge. So, this group will be having electron withdrawing effect, electron withdrawing group. That means it is the least stable. This will be stabilized by hyperconjugation. One CH3 here, another CH3 here, total 6 alpha hydrogen atom, stabilizing this carbocation. Anyway, aromatic rings are more stable than these types of ion. So, naturally, the most stable being this one, this molecule will have the maximum tendency to separate that Cl minus. So, B will be having the maximum tendency. So, what can be the answer? Then followed by A. So, B greater than A. You have to arrange them in decreasing order, mean B should be coming first. So, this can be the answer, B greater than A. Regarding C and D, I told you C is more stable than the last one. So, your answer will be second option, B greater than A, greater than C, greater than D. Yes, it is from actually first year. Option 2 is the answer. Next question. What are the functional group present in structure of maltose? This is from second year. Maltose consists of 2 glucose units, as you know. The skeletal structure you can write like this. This will be the anomeric carbon, and this will be the last one, 4th carbon. The other carbon atom I will not use it because that is not required. Another molecule of glucose will have a similar structure. Oxygen here, anomeric carbon. This will be the 4th carbon. This is 1, this is 4, this is 4. And here also there is a OH. So when 2 glucose units are joined by a glycosidic linkage, here water is eliminated, and after elimination of water, this bond becomes, after elimination of water, this bond becomes oxygen here. This way it goes. And what is a acetal group? Whenever carbon has got bonded to one oxygen, which is next bonded to another carbon, effectively there is a ether group, alkoxy group. Again, same carbon bearing another alkoxy group. Such a group will be called acetal. This has got acetal character. Here is a carbon attached to one oxygen attached to carbon, another oxygen attached to carbon. So this is acetal. This will be acetal. But what about this carbon? A carbon attached to an ether oxygen and also an OH will be called hemiacetal. So this is hemiacetal and this is acetal. Therefore, maltose contain both hemiacetal and acetal. Acetal and 1 hemiacetal, answer is 3. Answer is 3 from carbohydrate. Next question, number 3. The ionic radii, very simple question from the atomic structure, or you can even have it as a question from periodic table. This is the answer, direct answer. No. Maximum, yes sir, maximum size will be for O2 minus, bearing 2 negative charges. Then comes O, because the general principle is anions are bigger than cation. So O2 minus will be having the maximum radius. Next come another anion, fluoride. Next will be Na plus, and the one carrying 2 positive charges will be minimum in size. So size decrease is anion followed by cation. And among anion, the one carrying more negative charges. Then comes single charges. Then among cation, as the number of positive charge increases, size gradually decreases. So direct answer, answer 3. So your answer will be 3. Direct question, answer 3. Now to next question, number 4. A question from chemical bonding chapter, you can take it like this, because here is the concept of formation of a chemical bond. When 2 atoms approach each other, their potential energy decreases according to this diagram. Accordingly, see what are happening. What is stated is AD has the shortest bond length. Bond length is actually the distance between the minimum and this axis. AD cannot have the shortest bond length. This is the minimum on this curve. So this cannot be the minimum bond length. Minimum bond length is for this molecule. So 1 is wrong. AA has the largest bond enthalpy. Bond enthalpy is the depth of this graph. Maximum depth will be there for AB and not for AA. Bond enthalpy means the depth of this curve. So second also is wrong. AA does not have the maximum bond enthalpy. AB has the stiffest bond. Stiffest bond means strongest bond. Strongest bond. Strongest bond will be there for molecule having maximum bond enthalpy. Maximum bond enthalpy means this depth is maximum for AB. AB has the maximum depth there, so bond enthalpy is maximum. So this bond should be the stiffest bond. So the correct option will be 3. And nothing is given in this diagram that can lead to an idea about the electronegativity. That is only a 4th option, nothing else. Now you have next question number 5. An organic compound A Molecular formula C6H12O2. In acidic hydrolysis, give carboxylic acid and alcohol. So it should be an ester actually. And all these given molecules are esters. So not much data is help is there from the first statement. The only thing, it is an ester, that's all. But all these are esters. Now the next point is the alcohol. There is a property given for alcohol. The alcohol C immediately produces a precipitate with Lucas reagent. Testing, it is a tertiary alcohol. And what can be the tertiary alcohol here? It is given only by this option. Here the molecule will be CH3COO followed by tertiary butyl group. So naturally the alcohol formed in this case will be a tertiary alcohol, and that will give you precipitate with Lucas reagent. Therefore, your answer should be this one. അപ്പോൾ രണ്ട് ചോദ്യങ്ങളാണ് ഇതിൽ. ഒന്ന് എസ്റ്റർ ആണെന്ന് പറഞ്ഞുകൊണ്ട് ആവശ്യമില്ല, ശരിക്കും എന്തായാലും കമ്പൈൻ ചെയ്യാമത്. യു ക്യാൻ കമ്പൈൻ ദിസ്. എങ്ങനെ? ഒരു എസ്റ്റർ എന്ന് തുടങ്ങിയാലും കുഴപ്പമില്ല. An ester on hydrolysis gives an alcohol that gives immediate cloudiness, precipitate with Lucas reagent. അങ്ങനെ ആയാലും മതി. ആൻസർ അത് രണ്ടാണ്. The answer is therefore 2. Very simple question. This cannot, this is secondary alcohol only. This will be primary alcohol. This will be again primary. Tertiary is given only by 2. So your answer will be 2. Next question, number 6. Element with atomic numbers 101 and 104. The question is based upon lanthanides and actinides. You know, elements from 90 to 103. These elements are actinides. So naturally, element number 101 should be an actinide. So answer should be actinide followed by. And these elements are together placed in group 3. So naturally 104 should be placed in group 4. So it is only a knowledge of periodic table, especially actinides and lanthanides. 90 to 103 form the actinide group, and that is placed in group 3. So first part of the question is 101 belongs to actinoids, and all these are put together in group 3, and the next will be 104 will be placed in group 4. Therefore the answer will be actinoids and group 4, option 2. അത്രയേ ഉള്ളൂ. Next question, number 7. IUPAC's name of the following compound is from first year. The rule for naming cyclic compound will be, how will you choose the most important carbon atom? In the ring there is a COOH attached, which is having the maximum priority in functional group. So naturally this carbon should be in this molecule, the first carbon should be the one in which COOH is attached. So this is number 1, followed by number 2, where you have a CH3 attachment. This will be 3, and here you have bromine. So this will be 4. So name should start with 4-bromo followed by 2-methyl. Cyclopentane, ring is over. But because this carboxyl group is attached and this carbon is not a part of the main chain, this should be completely named as carboxylic acid. That is how you are getting the answer. See, 4-bromo 2-methyl, cyclopentane, carboxylic acid, number 1. You cannot number is cyclopentane. This actually cyclopentanoic acid is not possible because this carbon is not a part of the main chain. It is separated there. So to give the name such a way that carbon also is included in the name. പേരിൽ കാർബണും കൂടെ ചേർക്കണം. ഈ കാർബൺ നമ്പറിൽ വന്നിട്ടില്ല, അതുകൊണ്ട് ഇതിൻ്റെ പേര് കാർബോക്സിലിക് ആസിഡ്. The answer is 1. Next, number 8. Region in the electromagnetic spectrum where Balmer lines are visible. Direct question. Visible mean option 1, nothing else. Number 9. Among the element A, D statements A to D. Question from metallurgy, extraction of metal, metallurgical procedures. Actually all are correct statement. See that limestone decomposes to CaO in the blast furnace when you are adding CaCO3 limestone. immediately that will decompose into CaO and CO2. So statement 1 is correct. In the extraction of silver by hydrometallurgy method, silver ore will be converted to sodium silver cyanide complex, NaAgCN twice. So second is also correct. It's an anionic complex, dicyanoargentate complex. Nickel is purified by Mons process, correct, because nickel can form a carbonyl with carbon monoxide, which can be heated to produce pure nickel. That method is called Mons process. Therefore, C is also correct. And zirconium titanium, they can be purified by a similar method but not carbonyl method. They are allowed to form compound with halides are formed and then decomposes to form the corresponding alloy, and that method is called the Van Arkel method. So that way all statements are correct. A, B, C, D all are correct. Therefore, your option will be 2. It's a very simple question, but the only thing, statements are taken from different parts of the chapter. That you have to know. That's all. Next question will be 10. On combustion of lithium sodium S block element first year. You know, the small atom lithium cannot form a peroxide or superoxide. It can form only a monoxide. But sodium can actually form both monoxide and peroxide. Sodium actually can form this one, but when oxygen is in excess, that will form peroxide. And potassium actually can form K2O, K2O2, but it can also form next one KO2. In presence of excess oxygen, it can form KO2. So the answer you can opt is third option, Li2O, Na2O2 and KO2. Here what is wrong is, in excess oxygen this is not correct. K2 will not be formed. Instead it will be either K2O2 or KO2. Here this will not be formed. And the last one again Na2, present excess air, Na2O2 is formed. So your correct answer is 3. Question number 11 from equilibrium chapter. The condition for equilibrium, as you know, is rate of forward reaction should be equal to rate of backward reaction. And that is correctly represented only in option 1. This is the rate of forward reaction and backward reaction. Rate of forward reaction followed by A. Rate of backward reaction this one. And they are equal at this point. Curve will meet. It will not be like this. Here the curves will meet, but beyond that, that will not go up and down. Here rates are not equal. Here also rates are not equal. So the only possible answer is 1. At equilibrium, both rates are equal. What is wrong here is, at this point rates are equal, but after equilibrium further rate will not change. This one will not proceed to this direction and the other one will not go like this. That is what is wrong. Equilibrium is attained, but once equilibrium is attained, rate will not further increase or decrease. That is what is wrong here. So the answer is option 1. Next will be, which of the following will react with chloroform and alcoholic potassium? The question is based upon the amino acids. So naturally the question will be a characteristic reaction of primary amine. You know, a primary amine RNH2 can react with the chloroform in presence of alkali, giving HCl eliminated, giving RNC type foul smelling compound. That compound is called isocyanide, alkyl isocyanide or carbylamine. So effectively the question is, which will react with, that means which will give carbylamine dust. Which will give carbylamine dust mean which will contain primary amino group. That's all. Secondary amine will not answer this test. So effectively the question is, which molecule pair, which pair contain, both of them contain primary amino group. The answer is adenine and lysine. Adenine contains a primary amino group. You know probably the structure of adenine is given. Adenine is a hexagon followed by a pentagon. There is a NH2 group there, followed by a ring like the nitrogen will be there, and then you have got another nitrogen there. All these molecules are given in NCERT. The molecules are as such given in NCERT. Nitrogen followed by NS there, and this will be followed by this bond. It contains a primary amino group. That means it will answer this particular reaction. Lysine also contains basic amino acid anyway will contain. Lysine is an amino acid. It contains two primary amino groups. So that will also answer the test. Lysine will be NH2 followed by CH2 4 times, followed by CHNH2 and COOH. So these two primary amino group definitely will give carbylamine test. So the answer should be 1. Adenine okay, but thymine will not give it. It does not contain primary amino group. Proline also does not contain primary amino group. That is why the answer taken is 1. Next will be on heating. It's an inorganic question from second year. What will happen on heating or lead nitrate? It is actually lead nitrate. Lead nitrate on heating will give, as you know, a brown gas NO2. It is red brown gas NO2. This is A. But on cooling this A, it will become a solid with structure N2O4. That is colorless. This is paramagnetic, colored brown, diamagnetic, colorless. But on mixing with, what is the last one here? On mixing with NO, this compound actually in equilibrium. NO can actually combine with NO2 giving another product which is N2O3, and that is a blue solid. See, the correct explanation is given. On heating with NO changes to a blue solid which is N2O3. And question is, in this blue solid, what is the oxidation number of nitrogen? In N2O3, oxidation number of nitrogen is +3. So the +3 answer you can take, it is answer 3. It requires a knowledge of the chemical reactions occurring when? Chemical reactions occurring when the lead nitrate is heated, NO2 is cooled down. Again, what happens when NO2 combines with NO? A descriptive question from second year. 14th question. Match the following. The data will be found in surface chemistry chapter. Form, gel. It's a very easy question because gel easily matches with jelly. So 2C should be there in the answer. So first of all, see whether 2 is there in all. Here we have got 2C, here also 2C. So answer is either 1 or 2. And which one will be there? See, aerosol is actually smoke. 3A should be there. 3A correct here. We need not even further proceed. We will be getting on. Emulsion is actually milk. So 4F should be there, and that is given. So your answer will be 1. A rather very simple question from surface chemistry. Yes. So answer is 1. Next question number 15. The pair in which both species are the same magnetic moment. Let you have to calculate. It's from ligand field splitting or crystal field splitting method. Consider the ions given. Anyway, first I will give you the answer, then I will show you how you get the answer. എങ്ങനെയാണ് ആൻസർ കിട്ടുക എന്ന് അത് വെച്ച് പറയാം, അല്ലെങ്കിൽ സമയം വെറുതെ പോവുകയുള്ളൂ. മെത്തേഡൊക്കെ സെയിം ആണ്. ക്രോമിയം CrH2O 6 times 2+. അതിലത്തെ ക്രോമിയം Cr2+ എന്നാണ്. ആ ക്രോമിയം Cr2+. നെക്സ്റ്റ് അയേൺ ഓൾസോ ഈസ് 2+8. Fe2+. ഇതാണ് രണ്ട് അയോൺസ്. ഇനി ഇതിൻ്റെ സ്ട്രക്ചർ എഴുതി നോക്കൂ. Chromium is 3d5,4s1. This is chromium, but Cr2+ will be 3d4,4s0. And here also, this is 26th element. So 3d6,4s2 and iron 2 plus will be 3d 6 4s 0. See the difference therefore. This is containing only 3d 4 electron. This is 3d 6. Question is, even if we are not considering the ligand field theory, you will be getting the answer. Same magnetic moment. Anyway, let us go to the next part. They are all coordination complexes with water. Water is a weak ligand. So, how will you arrange the T2G level will be here and EG level will be here. Because the crystal field splitting energy is less, electron will be arranged like this. One here, next year, third year and the fourth one. 4 unpaired electron. But in this case also 1, 2, 3, 4, 5. As usual 1, 2, 3, 4, 5. But where will the sixth electron go? That will go here. So that will be paired. So unpaired electron is again 4. So they should have the same magnetic moment. That way you will get it. So your answer will be which one? 2. Similarly, you calculate the other cases, you will find this is the only possible answer. Answer 2. Next question 16, taken from EMF chapter, electromotive force. A fundamental principle of a reversible cell is, naturally when the cell is set up, it will be producing an EMF, reversible EMF, and that value given is obtained by the formula E cell equal to E cathode minus E anode. E cathode minus E anode. അങ്ങനെയാണ് അത് കൊടുക്കുക. അപ്പോൾ തന്നിട്ടുള്ള വാല്യൂ നോക്കുക. E cathode is actually cathode anode separation. Cathode is the right side, anode is the left one. Anyway, in this case, you know 0.34 will be the cathode and anode will be minus 0.76, 0.76. So when you add up, you will get value 1.1 volt. This is the reversible EMF, standard potential of the cell, and that is given also if the cell is 1.1 volt. Okay. Now what is the meaning of such a cell? After the cell is set up, if this cell is set up and the cell voltage is exactly 1.1, what is the cell reaction occurring? Zinc will dissolve and copper will be deposited, mean zinc will dissolve as per this equation, zinc plus cupric ion giving zinc ion plus copper. Zinc dissolved, copper deposited. So normally the cell functions like this. Now what will happen if an external EMF is applied? The external EMF you can gradually increase, and if you increase the value exactly to 1.1 volt, the cell reaction will be just stopped, no current flow will be occurring. That is exactly what is given here. If external voltage is 1.1, no flow of electron is possible, because the cell will push electron outward, but the external EMF try to push electron into the cell. Both voltages same, mean equilibrium attained, no current flow possible. Therefore, first condition is correct. Now what will happen if the external cell is less? If external cell voltage is less, the cell reaction will undergo forward direction. Zinc will dissolve, copper will be deposited. This condition number 2. If cell is external EMF is less than 1.1 volt, zinc dissolves and copper deposited. Cell reaction proceeds in forward direction. So 2 is also correct. But if the external voltage is greater than 1.1, what will happen? Reverse reaction should occur. Reverse reaction should occur, mean what will happen? Normally current is flow, electrons are flowing from zinc to in this direction outward, from zinc to copper normally. But if the external EMF is greater, electron will flow in the opposite direction, but is given 3. If external EMF is greater than 1.1 volt, electron flows from copper to zinc reverse direction, so that is also correct. If you are normally leaving the cell to work as such, zinc will be supplying electron, copper will be accepting electron, electron flows from left to right in the external circuit. But the external voltage is greater, reverse will be taking place. and that is exactly even here. But the fourth one is wrong, because if external voltage is greater than 1.1 volt, reverse reaction should occur. That means zinc cannot dissolve. What is given in option 4 is external voltage greater than 1, zinc dissolve. The same reaction that is mentioning. Zinc cannot dissolve, reverse should occur. So that is what is wrong. Therefore, correct options are 1, 2, 3. But question is, which is the incorrect statement? Incorrect means answer 4. Your answer is 4. Next question number 17. For 1 mole of ideal gas, very important point, 1 mole is given. Amount is fixed. Once amount is fixed, internal energy and enthalpy depend only on temperature. Otherwise, generally the statement will be internal energy and enthalpy of a gas, ideal gas, depends upon 2 conditions, amount as well as temperature. But in this case, amount is fixed means that cannot be varying, only variable is temperature. So statement A is correct. A correct. Because amount is fixed, internal energy depends only on temperature. Compressibility factor set should be equal to 1. That is given as wrong. So B is wrong. Cp minus Cvr is correct. And du equal to Cv dt is also correct. So correct options will be A, C, D. Question is, correct option will be A, C, D mean option 4. What is wrong with the B is compressibility factor also should be equal to 1. Not equal to 1 is wrong. Answer therefore 4. 18th question. Again a small question from second year. A compound P on treatment with bromine FeBr3. See, bromine FeBr3 is a standard reagent for aromatic substitution, electrophilic substitution. And on such a reaction, what is given is, it produces only a single isomer. Generally, suppose there is a group already present in benzene ring. It will direct the next group either to ortho para position or meta position. So there are possibility for getting more than one product. This group is actually, even though there is a COOS there, this group is essentially electron donating group. It will direct the next bromine to ortho and para. So this will give minimum 2 compound. What about this one? This COOH is meta-directing. COOH is meta-directing and CS3 is ortho-para-directing. But effectively in this ring, the ortho position of CS3 is the same as meta position of COOH. So effectively only one place is favored. It will be at this position that substitution occurs. In this ring, for example, even though there are 2 groups attached, both groups are directing the next group to the same position here. Ortho with respect to CS3 and meta with respect to COOH. This will give only one product. So the answer can be 2 only. Here also there can be more than 1, here also more than 1. And 2, make sure that it is the same option correct. Next one being on treatment with soda lime. It gives toluene, it will give toluene because soda lime treatment will decarboxylate this acid. It will decarboxylate. So you are getting toluene. Answer therefore will be 2. Next question. Number of isomers possible for PTEN-NO2 twice. See, a PT complex is actually square planar. En may be attached there. NO2 can be here. But En is a symmetric group. It is not similar to glycinate also. It is symmetric. So you cannot expect a cis-trans isomerism. Okay. So what is the possibility? NO2 can have 2 structures. NO2 can be either NO2 or ONO. They have given only NO2. That means possibility will be you can have both positions occupied by NO2 both occupied by ONO, and third possibility, one NO2 and the other ONO. That way there can be 3 isomers. That is it. Therefore, the answer will be 3. Option given 3. Answer 3. Next will be 21. When neopentyl alcohol is heated with the acid, it slowly converted into an alkene. What is the possibility? Neopentyl alcohol actually contains C, CH3, 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 CH2OH. And on treatment with acid, first of all, it will be protonated, then water is eliminated, and you are getting a carbocation, which will be CH3, 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 followed by CH2 plus. Being a primary carbocation, it will try to stabilize itself by this shift of methyl group. So immediately that becomes CH3, CH3. This CH3 will be attached there, mean it will be CH2 followed by CH3. Positive will be shifted to this carbon and this becomes a tertiary carbocation. Methyl shift makes a tertiary carbocation. And to complete the dehydration process, you have to eliminate a proton. It can be either from here, both are equivalent, either from here or from here. Theoretically, there are 2 possibilities. I don't say it is, one is both are equally stable, no. One will be more stable, even then there are 2 possibilities for the formation of alkene. Removal of this hydrogen will give an alkene with the structure CH3C, CH3C, followed by double bond CH3. It is this proton that is eliminated. And removal of one of this hydrogen either here or here will give CH2 double bond CH3 followed by CH2CH3. These are the, and that option will be, see there, CH2 followed by C and ethyl methyl group. CH2 followed by one methyl and the other ethyl. This is correct. And how do you describe this one? This is CH3 twice C followed by CH3. CH3 twice followed by CH3. So you have the option 3. What is wrong is, in this case, for example, CH2 double bond CH, that is not there. CH2 double bond CH is not. CH2 double bond C and CH3 and ethyl, methyl-ethyl combination. You don't have CH2 followed by, if there is CH2 formation, the next carbon will not have a CH anywhere. So answer you have to select by looking at all the structure. The answer is 3. The reason being, a shift of methyl is possible to stabilize the carbocation. A methyl shift കൊണ്ടാണ് രണ്ട് product കിട്ടിയത്. Possible ആയിട്ടുള്ള രണ്ട് product ആ പറഞ്ഞത്. Of course, this will be more stable than this one. പക്ഷേ more stable ചോദിച്ചിട്ടില്ല. Possible ആയിട്ടുള്ള structures. അപ്പോൾ answer ഇതായിരിക്കും. So the answer is 3. Next will be mass of ammonia. So very simple question. Anyway, work out it. You know, nitrogen plus 3 hydrogen can give ammonia. And as per this equation, 28 gram or kilogram nitrogen can combine with 3 into 2, 6 kilogram hydrogen, giving 2 into 17, 34 gram ammonia. 28, 6 and 34. In terms of kilogram also it is correct. Kilogram. But what is given is 2.8 kilogram nitrogen. So make it 2.8 kilogram here. So theoretically that requires only 0.6 kilogram hydrogen. And we have taken 1 kilogram hydrogen, mean this is in excess. Requires only 0.6, we have taken 1 kilogram. That means it is for excess. Therefore, this is the limiting reagent. Nitrogen is the limiting reagent. So you have to calculate the mass of ammonia from the mass of nitrogen. Then proceed. 28 can give 34 ammonia. No, 17 into 34. So 2.8 gram give 3.4 gram kilogram ammonia. It is 3.4 kilogram, and that will definitely work out to 3400 gram. So the answer will be 3400 gram. This numerical value is 3400 gram. Next question 22. If 75% of first order reaction was completed in how many? Completed 90 minutes. 60% will be completed in how much time? First order reaction, you know, the time required for completion of a finite percentage is T equal to 2.303 by K log. Because it is in percentage term, I can write 100 divided by. Suppose the first part is time required for completing 75%. The remaining will be only 25. So this will be 25. And if this time is, the first case, the time is 90 minutes. So if this is 90, 75% reaction completed in 90 minutes. So time is 90 and the remaining is 25. First equation is obtained. The second case is this should be 60% completed, but the time we don't know. So time is equal to 2.303 divided by K log 100 divided by remaining is only 40. 100 by 40, 60% to be completed. So find the ratio, divide. I will write the other way. T by 90 equal to T divided by 90 equal to, this cancels, log will not cancel, of course this will be log, I can write 2.5, 10 by 4, 5 by 2, 10 by 4, so it is 2.5 divided by, this will be log 4, and luckily the values are given. Log 2.4 is 0.4 divided by log 4 is log 2 squared. So 2 log 2. So 2 times 0.3, it is 0.6. So equal to 2 by 3. So T by 90 equal to 2 by 3 means T will be equal to 90 goes there, 90 into 2 divided by 3. It will be 60. That way you get the answer 60. That's all. Your answer will be 60. First order rate law you apply directly. No problem for calculation, values are given. Next one, question 23. It is a question from solution chapter. You know, when two liquids are mixed together, you are getting an ideal solution. Reynolds law can be applied for calculation of total vapor pressure, which is P total equal to P0A into XA plus P0B into XB. This way you can apply. Now you have got two solutions here. The first solution is prepared by mixing 1 mole of normal hexane with 3 moles of normal heptane. This is heptane, this is hexane. That means mole fraction of hexane will be 1 by 4.25. Mole fraction of heptane will be 3 by 4.75. So write down the equation. Let this A represent hexane and B represent heptane. So we'll write the equation as, for hexane we don't know the vapor pressure, P0A into 0.25 plus, for the other one we don't know, P0B we don't know, but XB you know, it is 0.75. This is equation number 1. Now what is given is, when you are adding 1 mole of, what is that, at the same temperature, if 1 more mole of normal heptane is added. So along with that added heptane, this amount become 1 here, but the other become 4 moles. So that the first mole fraction become 1 by 5 equal to 0.2. and the second mole fraction become 4 by 5 equal to 0.8. And for that, the total vapor pressure increases by 10 mm mean this total vapor pressure is given as, in the first case, it is given as 550. So you can actually write this as 550. In equation 1, the total value given is 550 equal to, you can write. In the second case, you can write 60 equal to P0A, mole fraction reduces to 0.2 into 0.2 P0B multiplied by 0.8. Now the remaining will be just a solution of these two equations. By making one of the same, you multiply this with 4, so that this become P0A. Multiply this with 5, so that this become again 1. Then subtract and calculate. Then you will be getting the answer finally. That remaining calculations being very simple, the answer I will give you, the answer finally obtained will be P0B will be 60 only. Nothing else. Simply multiply, subtract and evaluate P0B. The answer will be 60. That's all. Then 24. The number of chiral centers present in B is, there are two reactions given. Methyl magnesium bromide and ethyl magnesium bromide reacting with a alkyl cyanide. You know the alkyl cyanide, let it be RC triple bond N. It's a standard reaction of Grignard reagent with cyanide. Let us take the cyanide CS3 MgBr. CS3 will be added to carbon, MgBr to nitrogen, giving RCCS3 double bond N MgBr. Simply adds to Grignard reagent, adds to this C triple bond N. And on hydrolysis, oxygen will be coming over there, hydrogen will be there. So this part become H2N MgBr. That is not required for us. But the other part is a ketone. That is the most important point. Whenever an alkyl cyanide reacts with a Grignard reagent, it will be converted to a ketone. And next will be a ketone can again react with a Grignard reagent. And that final product obtained will be, it will be a tertiary alcohol. That part is a standard reaction. So apply this principle. Your first compound is a compound with the structure given. This is CHCS3. This part is remaining as such. But after the first step of the reaction, what is Grignard reagent used is C2H5, mean you will be getting a ketone with the structure CO C2H5. So if you study this step by heart, cyanide Grignard reagent reaction product hydrolysis, if it is a ketone, directly you can apply the step. And next step will be again that is reacting with a methyl magnesium bromide Grignard reagent. So the tertiary alcohol obtained will be this one. Tertiary alcohol obtained will be CHCS3 followed by COH. Original C2H5 will be there. But the second Grignard reagent is CS3. Therefore, this is the tertiary alcohol finally formed. So the final product is this one. Question is, number of chiral centers possible in this molecule. How many asymmetric centers are there? Definitely this is one asymmetric center. CS3, C2H5, OH and the remaining part. This is another asymmetric center, CH-CS3 followed by this group. And in this ring itself, you have got a third asymmetric center. This is a asymmetric group, carbon, and this also is a asymmetric group. Attached here you have got hydrogen, CH3, then CH2, 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 etc. Here only CH2. So there are 4 asymmetric centers. So the answer for this question is 4. That way, question number 24 is over. This last question, 20 ml solution containing 0.2 gram hydrogen peroxide reacts completely with 0.316 gram How will you attempt it? It's a reaction based upon redox step. Now, hydrogen peroxide decomposes to give one atom oxygen. You can take it like this. But in acid medium, KMnO4 can give 5 oxygen atom. Complete equation is 2 KMnO4 plus 3 H2SO4, etc. Finally, that will give 5O. Or you can attempt in terms of oxidation number method also, no problem. So, when they combine, each KMnO4, sorry, 2 KMnO4 can supply 5 oxygen, mean 5 H2O2 also had to supply 5 oxygen atom. Then only 5 oxygen obtained from H2O2 will react with 5 oxygen obtained from KMnO4, giving 5 O2. That's the way it reacts. In terms of oxidation number also the same answer you will be getting. In fact, KMnO4 reacts with hydrogen peroxide in the ratio 2:5. For 2 KMnO4, you require 5 H2O2. Now, in terms of masses, you can take, or you can have it 1 KMnO4 required 2.5 H2O2. This knowledge you have to know. Now, 1 KMnO4 means how much? A KMnO4 molar mass is 158. So, 158 gram KMnO4 will require 2.5 H2O2, mean 2.5 into 34 gram H2O2. But in this case, what is given is, this is impure hydrogen peroxide. So, you cannot use it. 20 ml solution containing 0.2 gram impure. So, you cannot depend upon the 0.2 value, but the 0.316 is dependable. Here, 158 gram KMnO4 can react with 2.5 into 34 grams of H2O2, that is right. But the actual mass of KMnO4 utilized is only 0.316. So, if this is 0.316 gram, how much will be this hydrogen peroxide mass? Hydrogen peroxide mass will be 158 correspond to this value. So, 0.316 correspond to how much? Ratio we can equate. 158 divided by 0.316 should be equal to 2.5 into 34 divided by unknown value. And this unknown will actually be 0.17. This unknown will be 0.17 gram. That way you could. So, the amount of H2O2 reacting with 0.316 gram of KMnO4 is only 0.17 gram. But if the solution is supposed to contain 0.2 gram H2O2, it is supposed to contain 0.2 gram H2O2, but chemical analysis shows it contains only 0.17 gram. So, out of 0.2, 0.17 is H2O2, the remaining will be impurity. Impurity will be 0.03. This is 0.2. So, what is the percentage purity of the sample? Purity will be pure sample 17, impure sample 0.2 into 100. And that will give the answer 85%. It will be 85%. That way, the answer for the last part is 85. So, that much regarding this paper. All questions are beautiful question. See, there is a possibility for confusion here. See, don't take it 20 ml solution containing 0.2 gram. So, actually it is that 20 ml that contain 0.17 gram. 0.17 gram is present in 20 ml. So, how much is present in 100 ml? Such a calculation is not possible, because what you require is the percentage, not of solution. You are not asked to calculate the percentage purity of the solution. You are asked to calculate the percentage purity of hydrogen peroxide. So, the weight of hydrogen peroxide originally taken, actual weight of H2O2 chemically found into 100. So, this 100 ml will give another result, which is 5 times this value, which is 0.85. But that is not the answer. It is only expressing the amount of H2O2 in 100 ml of the solution. That is not what is required. What is required is you are given 0.2 gram H2O2. Out of this, what is the actual mass of H2O2 present? So only 0.17. So at the percentage, 0.17 by 0.2 into 100, it is 85. That's all. Okay, thank you.